How many of those were water? 34. All right. So what percentage is that?
68.
Look at you. Fast math.
I need an eraser.
Good job. 68%. We're close to 70, aren't we?
Yes.
Hey, what do you know? Okay.
It's really cold.
You just complained it was too warm. So
I liked it. Make it too warm.
Yeah, make it more.
I'm not messing with it. All right. So here we go. I'm going to walk you through the 4-step process that we're going to use to do the intervals. Because here's the thing. You have to check assumptions. You have to state what we're looking for. And if you follow this 4-step like little checklist, you're going to have every element to the question done. All right. So it's just a formatting thing to make sure you're covering all your bases. So the first step is the state step. Okay. What is it we're trying to predict? What parameter are we going for? In context, what is it we're trying to figure out?
How much water is on?
Can you be more specific, like average or percent? Okay, so it's P, the percent of water where? On the earth. The percent of water on earth. Well, I know that. It may feel obvious, but it's okay. All right, that's the first step, is identifying what is it we're trying to estimate. All right, we can't logistically do all the water in all the earth, so we take samples, right?
Yes.
Yes, okay. And at what level of confidence do we want to be? What does it state?
I'm pretty confident.
95% confidence. Okay. So, name of the procedure. The procedure we're using is a 1 proportion Z interval. That might feel really obvious to you, but before we're done, there's going to be multiple intervals and multiple tests we can do. And it's fine. We'll just baby step our way through. Promise. It follows a pattern. There's just small little tweaks here and there. All right? 1 proportion Z interval. Now, checking the conditions. There's 2 conditions. Remember we called them assumptions Friday? TW calls them assumptions. Do you remember what they were?
No.
Can you look back at that simulation we did Friday and just flip the page and remind yourself real quick like? Random sample was the first one. Okay. So I have to check our process. Was our sampling random?
Yes. Yes.
Bailey, would you think that our sample was random?
Yes, very random.
Very random. Yes. And we're going to go, it's random. All right. Sometimes you say yes and it's stated, but this time we actually collected the data ourselves. We know it was random. Okay. And then what was the other condition? Okay. Large counts for the purpose of knowing if it's normal, right? Large counts because it's proportions. So it's that n times p hat, because that's all we have, right? N times 1 minus p hat greater than or equal to 5. So let's see. Is 50 times, what was our p hat? 0.68? Okay, well, we know that that's 34. That's definitely greater than 5. And 50 times 0.32 is 16. That's greater than 5. So it's just the raw numbers that we got. Yeah, it is. Because that's how we ended up with the 0.68, right? Taking the raw values and dividing them. Well, I mean, it's a good thing to recognize because it's like, oh, okay. Sometimes you'll get the question and it'll only give you the raw data and you have to come up with the p hat. Sometimes they give you the p hat and you have to go back and find the numbers, but you always do it in this large counts test anyway. Okay? So we know it's normal because it passed. Okay? That means we can move ahead and use norm CDF. We can use z-scores. We're good to go. All right? Now, if the conditions are met, which they're going to be met, perform the calculations. All right. Now, specific formula for the interval. It's just to remind you of the formula. It does this. It starts with your point estimate, and we call that p hat, our sample proportion, or our point estimate, plus or minus the z star, or we call that also the critical value. times the standard error. This is where we take p hat times 1 minus p hat over sample size and square root it. Okay, so let's plug in some numbers here. P hat was what? 0.68, plus or minus. Okay, critical value. We talked about these Friday. We said if we're 95%, we're almost 2 standard deviations away from the mean. Do you remember what the critical value was? Those are the z-star things. If you just flip that page, there you go, 1.96. If you flip that page, you'll see that 95% is a really common confidence interval use, so you'll use 1.96 quite a bit. All right? Do you remember how to get that? Remember how we drew the little picture and we said, okay, if 95%'s in here, what's in the tails? And then you do the inverse form thing.
Oh, yes.
That's how we got there. So if you needed something besides 95, you can get there. Yeah? All right. Okay, then we got to do this piece. Oh, not p hat. I'm going to actually use values here. 0.68 times 0.32 all over 50. Square rooted it. All right, let's crank some numbers out. Let's do the, I'm going to do the square root guts first. So I get 0.68 plus or minus 0.129. Which gives me 0.551 0.809. And just as a rule of thumb, as you're putting this in your calculator, like I do this first, do the square root, then I multiply it by this, and it gives me this long decimal answer, right? I would refrain from rounding that long decimal until the very, very end. So it stays in the calculator memory. So then all I would have to do is say 0.68 minus, and then copy paste that long decimal, 0.68 plus that long decimal, and then at the end is where I would round to 3 decimals. Okay. If you round earlier, your answer is going to be slightly different. All right. So that may be where you see differences. So this is saying that we think the true percentage of the Earth covered in water is somewhere between, what, 55% and 81%? Funny. Isn't that what we were told? All right. Interpret the interval in the context of the question. So there's that sentence thing we got to use, right? It says, we are 95% confident that the interval .551 to 0.809 captures the true proportion of the Earth covered in water. So the part of this structure, sentence structure you'll use every time is we are whatever % confident that the interval from blank to blank captures the true fill in the blank context. All right? Those parts will always stay the same. Obviously, their question's going to change. It's not always going to be about water. Now, number 4, we're going to save that for 8.4. That's an 8.4 thing, so we're not going to do that one today. Okay? Flip on the back. We're just going to recap real quick the 4-step process. Okay? The first step was to state the parameter. Nick, I know it's exhausting, but we haven't really done that much work. State the parameter we want and how confident do we want to be. All right, that's just reading the question. It's usually stated in the question. Name the procedure. So this is the plan step. Name the procedure. Right now we only have one. It's the 1 proportion z interval. And you can abbreviate it, that's fine. The conditions or assumptions, do you remember what they were?
Random and large count.
Yeah, random sample. And we got to check that it's normal using, in this case, large counts, okay? So those are the 2 conditions I have to check. General and specific formulas, plug the numbers in, calculate the interval. This is all you really have to worry about is writing your formula with your values in it. Obviously, you're going to use a calculator to crank it out, right? And then calculate your interval. So this is the do step where you actually do the math. Show your work. State, plan, do, and then we conclude. This is where we tie a little bow around the problem and put it back in context. Yes, bows. Yes. It's a little package, right? It's a whole package problem, start to finish. So, can we handle that? Yeah.